Hey everyone, and welcome to a brand new series that I'm super excited about on making a 2D tile game in Scratch inspired by games like Paper Minecraft, Miner Cat, Cube Miner, and even Terraria. I've been working on this game for the past several months and I'm super excited to show you guys. So if I go ahead and full screen the game and click start, as you can see here, there's a nice loading screen that kind of hides the world generation, and I'm really happy with how this game turned out. As you can see, it's a nice pixel art game where we can move around and we have this nice hotbar, we can jump, there's a background, and there's a bunch of tiles. And this world is randomly generated each time we start the game with all these preset tiles. And as you can see here, I can click to actually use a pickaxe to mine stuff. So I'll go ahead and mine up this dirt tile. And as you can see, there's some nice particles and I get this dirt tile. As you can see, there's a full inventory system where we can collect items and all that stuff. Every tile has its own parameters, such as if it has collision or not. As you can see, this one doesn't have collision, if you can spawn on it, how long it takes to mine it, what item it drops. There's item systems. You can even place blocks back down, so you know, I could block. There's also some cool feature generation, such as trees. They all have randomly generated heights, as you can see here. So the main part of the game takes inspiration from Miner Cat, where you have to go get blocks and then sell it to a shopkeeper. So you spawn on this little platform, and then you can go up to this person and click E to open the shop. And as you can see here, this little dude says welcome, and our hotbar kind of moves to the right. And then there's all these shop items. And the cool part about this shop is that it actually uses a system to where once this item gets to the top, it teleports to the bottom and then switches all of its IDs and all that stuff. That means that we can have an infinite amount of items in the shop. There's no limit to how much you can have. Each item has parameters for if it's in the shop, how much it sells for, how much you can buy. And now that I'm actually in the shop, let me show you the selling. So I can click on this dirt, then I get 4 because there's 4 dirt and dirt is just 1 apiece. That's one of the item parameters. Better tiles give you more money, and the better tiles spawn underground. So now that I have some money, I'm going to go ahead and buy 2 torches and sell my leaf here and buy a ladder. Another thing you might have noticed now that I have a torch is the lighting engine. As you can see, there's a pretty basic but still functional lighting engine in this. So I'm just getting some tin here, and as you can see here, when I go underground, it kind of lightens up. Or if we place down this torch, as you can see, it actually gets brighter, which is really cool. So you can use this to kind of make light. I'm going to do some parkour over here. Alright, so now that I mined some stuff up, I'm just going to sell all my stuff, and now I can buy a bunch of ladders. Okay, so this looks pretty good, and now I can actually start making like a mine. So I'll go ahead and dig down to get to some better areas. So if I dig deep enough, you can see that the background changes to this cool like dirt background, and then it gets darker and darker. So this is when it starts getting useful to use torches, because I can light this up and it looks nice. Now I'm going to go ahead and place some ladders so I can get back up to the surface, and you can see that there's this little animation of you climbing, and now I can get back to the surface nice and easy. And here we go, I made it to the stone layer. As you can see, the stone is extremely hard to mine, so that's why you want to get better pickaxes from the shop. So I'll go ahead and go back up to the surface, sell my stuff, and get some more money. Okay, so I totally just got 4,577 gold, legit. I didn't use a command, and now as you can see here, the very first pickaxe is 50 gold, and I can go ahead and click on that, and it actually buys it. It kind of darkens it to let us know that we bought it. And now when we swing our pickaxe, look at this, we have a stone pickaxe, and it mines a lot faster. This is where you can start upgrading to get better gear. The cool part about all these systems is once you set up all the backend code for it, it's extremely easy to add new tiles and items. You just have to make the correct item meta and then make the graphics, but other than that, you really don't have to program at all to make new items. So obviously, as you keep digging and doing stuff, you can keep getting better and better ore to get better pickaxe. Like here's a tin pickaxe, as you can see, and I can dig everything up, and you can see that it's starting to get much faster and better and quicker to collect stuff. If I go back down here, you can see now that, look at this, I can mine stone at almost a normal pace. It's not so painfully slow with the tin pickaxe. Also, there's ore generation in this game, which is pretty cool. As you can see, there's some coal over here, and you can specify the size of the ore and all that stuff. So now I can get the copper pickaxe, and as you can see here, look at that. That is much better for digging. You can kind of moonwalk if you hit in one direction and move. Okay, but anyway, as you can see here, this is getting much better, so we can actually start digging much deeper in the world because it doesn't take so long. And as you can see here, there's actually copper if you go deep enough into the stone layer, and also the background changes to the stone, and copper sells for a lot. I think it's like 10 a piece, but my inventory is full right now, so I can't pick these tiles up. It's also pretty dark down here. I've got to get a torch. And as you can see, there's a ton more pickaxes. There's like this silver pickaxe you can get, and it mines even faster. Okay, so now that we have a silver pickaxe, which is pretty good, I want to go deeper in the world to get better ore that makes more money. Because down deep enough, there's silver and gold, which silver sells for I think like 25. So I'm going to go down this ladder, and then I'm just going to see if I can dig down all the way to silver. And obviously, if you're doing a real playthrough without cheating, you would want to go back up and build ladders and make it nice and walkable so you don't get stuck in a hole like this. Okay, so as you can see here, I've dug down here, and this was from earlier when I was testing, and I actually found this vein of silver, which takes a lot longer to mine, but it is super good and it sells for 25 a piece. If I dig even deeper, there's some more silver. More silver. Wow, there's a lot of silver in this area. Oh yes, I finally found it. I can find gold. Oh, there's some down here and to the right. It's kind of an interesting sprite. Almost looks like amber. The gold is super good. It sells for 50 a piece. But the trade-off is that you have to go really deep into the world. There's also like tile dependencies. So if I place this grass on top of this dirt block and break the dirt block, you can see that the tile on top gets broken because it's marked as only being able to be on the ground. Yeah, overall, there's a lot of cool mechanics and stuff for you to do. I'm not going to spoil all the pickaxes because I want you to play through and see for yourself. I hope you guys like this game and are excited to make it because I've spent a ton of time making all the code and art for it. I'm super excited for this series, and if you are, then make sure you hit that like button and consider subscribing. We have a lot to do, so let's just hop right into this tutorial. Also, this is a game I sneak peeked in my community video, by the way. Alrighty, so I am in a brand new project with just one sprite called Tile Manager, and this is like the brains of the tiles. Within it, I have a costume called 1. This is just a temporary costume, but we'll use it in the final game because this is the stone tile that I created. And this sprite is 16 by 16 pixels or 8 by 8 in the costume editor. What I mean by that is it is pixel art, obviously. You can see the pixels, and if I count here, 1, 2, 3, 4, 15, 16. As you can see here, this is 16 pixels wide and also 16 pixels tall. A quick tip for you if you want to make a easy 16 by 16 pixel art is just by making a new sprite and zooming in on your canvas and then making a square that fits in these 4 squares. That right there is perfectly 16 by 16 pixels or 8 by 8. You can technically follow this tutorial in a different resolution, it's just some of the stuff isn't going to match up. So if you want a smoother and easier time making this game, I highly recommend you make your art 16 by 16 pixels. And if you want to get this little stone tile, then there'll be a link in the description to the art page for this game. Or you can just draw a square that's 16 by 16 pixels. This project is going to end up being pretty big, so I highly recommend you download Scratch add-ons because it helps manage bigger projects using like developer tools and Cleanup Blocks Plus and all that stuff. If you need help with that, then check out my tutorial on Scratch add-ons. Okay, so let's go ahead and pull a when green flag clicked out, and now we need some variables to set up the scaling and stuff of our tiles. So make a for the sprite only variable called tile scale. So this is exactly what it sounds like. If the tile scale is 1, that's size 100. If the tile scale is 2, that's tile size 200, and so on and so forth. So for me, I want the tile size to be 500 because that means with a 16 by 16 costume, it will perfectly fill up the screen once we get enough clones. So the scale for that would be 5 because 100 times 5 is 500. So now we need a variable to keep track of the size of the costume itself. So make a for the sprite only variable called tile sprite size, and we'll go ahead and set the tile sprite size to whatever your sprite says, which mine is 8 by 8. So if you're doing a 16 by 16 thing like I am, then put 8 in here. Now with those two variables, we can calculate the amount that each tile should move. So what I mean by that is if I want this tile to perfectly move one tile, how many pixels is that? That's actually super easy to calculate. So let's store that in a variable as well. This is just for optimizing. That way we don't have to do the calculations over and over again. Make a variable called tile move step. Set that tile move step to a times operator and take tile sprite size times the tile scale. And as you can see, if we start this game, everything gets set and the tile move step is 40. Then you want to make sure you set the size to the tile scale times 100. So now that we have this all set up, you can see that our tile is nice and big and all the variables are set up correctly. So now that we have this, we can go ahead and set the X to tile move step times 0.5 in the very beginning, and then repeat set the Y to the tile move step times 0.5 as well, which is just dividing it by 2. Now, as you can see, when we start, it's kind of slightly offset to the top. Now we need to generate a grid of tiles that will perfectly fit on screen, which will look kind of weird because they'll be offset from the screen. They won't start in the bottom corner. It'll kind of start in the middle of the screen and then go up. So to do this, add another repeat in here, just do 10 for now, and then create a clone of myself and change the Y by the tile move step so it moves one tile up, and then at the very bottom change the X by the tile move step like this. And you can see if we start this, it creates this grid like so. Now we need to figure out the right amount of tiles for the X and Y. So let's go ahead and make a sprite called tile amount X like so, and then tile amount Y. Both of those are for the sprite only. Next, we can set the tile amount X and Y to 0 for now, and then repeat the tile amount X here and the tile amount Y here. Now for the tile amount X, we want to set this to blank plus 1, and then add a abs of and change this to ceiling of, and then a divided by. Now we want to take the width of the screen, which is 480, divided by the tile move step, which will give us the amount of tiles for that screen. Duplicate that and set the tile amount Y to all this, but change the 480 to 360, which is one screen height. And now you can see if we show the tile amount X and Y, the X is 13 and the Y is 10. Now we really can't tell if this is a perfect screen or not, so we need to make this game scrolling so we can move the camera up to the top right, because the origin of the world is perfectly 0, 0 in the middle of the screen. So let's switch this to scrolling. Now the way we can do this is to change all these Y's and X's to a custom variable. So make a for the sprite only variable called tile X, and then another one called tile Y. These will keep track of the position of the tile. Now right here, set the tile X to the tile move step times 0.5, set the tile Y to tile move step times 0.5, change the tile Y by the tile move step, and then change the tile X by the move step here. You're just swapping them out for the variables. So let's go ahead and make a tick loop that will position the tiles. So in the backdrops, add a when green flag clicked forever broadcast message. Make a new one called position, then tiles like so. Now inside the tile manager, add a when I receive position tiles, go to the tile X and tile Y. And if we set everything up correctly, you can see that it's back to how it was, creating them on the corner of the screen. Now we can actually make this scroll. So add a public for all sprite variable called scroll X, and then another one called scroll Y. And for now, in the beginning here, let's set both of those to 0. And I'll do that right here. Now in the tiles, let's do go to tile X minus the scroll X, and then tile Y minus the scroll Y. So you can see that it still works the same, and that is good. Make sure yours is working just like mine, otherwise the rest of the tutorial probably won't work. Now you can see that if we switch the scroll X and Y to the sliders, you can see that we can actually move the tiles around like we're moving the camera, which is cool. That is working good. And really quick, let's go ahead and set the scroll X to center these tiles. So on the bottom here, set the scroll X to the tile amount X times 0.5, so it's half of the amount of tiles, and take that times the tile move step, which is the amount each tile moves, and do the same thing for the scroll Y, except change this to the tile amounts Y times 0.5. And you can now see if we start this game, look at this, it perfectly creates the amount of clones that fill the screen, and everything lines up perfectly. As you can see, this is a perfect grid of sprites, and we can even drag them and it will snap back into the correct spot. Make sure that everything is working exactly how mine is up until this point. It should be making a perfect grid that fits on your screen nicely. Okay, lastly, let's make this happen instantly so we don't have to watch it generate the clones on screen. So make a custom block called generate clone grid. Then make sure you check run without screen refresh, and go ahead and run this on when green flag clicked and put all of this inside here. And I'm going to go ahead and put the set size on the very bottom just because it looks kind of cleaner. Now you can see if we start the game, instantly a bunch of clones pop up. Awesome. Okay, let's also make a simple camera system so we can move around the camera just for testing. So change the scroll X by key D minus key A, and then take that times a number like maybe 5. Put that in there and duplicate it and do the same thing for the Y. So change the scroll Y by W minus S times 5. So now you can see that the camera will perfectly generate all the clones. Then we can use WASD to actually move them around. Now there are some issues. As you can see here, there's a little tile at the end, and this is actually the sprite. If we click on on the tile manager, you can see it highlights right there. All we need to do is add a show before we generate the clone grid and then hide after. Now you can see that that little tile is gone. Now the other issue is if I full screen this and move, you can see that the tiles get stuck on the edge of the screen and it looks absolutely hideous. So let's make it to where it's seamless. So there's actually a really simple trick. All we need to do is make the size really big on the sprite and then reset the size. So that'll make it be able to go off screen because it's bigger. So if I go ahead and set the size to a really big number right before, like 100,000, I go to the correct position, then I set the size to the tile scale times 100. You can pull that out from there now. If we go ahead and start the game, it seamlessly goes off screen and you can't see it getting stuck because of the little size trick. And that looks really great because now we have one perfect screen of tiles. Okay, so now on to the more complex part of this episode. So you may be wondering how this game works, because each world is thousands and thousands of tiles big, but Scratch has a limit of 300. So how this game does it is once the tile reaches the very edge of the screen, it loops on the other side and then switches its costume and its ID, so that way it switches all of its data as well. So for this episode, I'm just going to be showing you how to actually make the tiles loop, not the actual switching the ID and stuff. That'll be for a next episode. So to do this, we want to make a custom block called loop tile with a colon and then an X with a colon, input X, a label called Y with a colon, and then an input Y. And you make sure you check run without screen refresh and click OK. Now all you need to do is loop the tile on the beginning of the position tiles and input the tile X minus scroll X and tile Y minus scroll Y. Now we need to figure out the maximum position our tile should be before it loops. So make a for the sprite only variable called tile loop cap and set that to the tile amount X times the tile move step times 0.5. Make sure it looks exactly like this. And as you can see, my tile loop cap gets set to 260, and yours should too if you're following along with 16 by 16 sprites. Now we want to go ahead and check if the X is greater than the tile loop cap. And if it is, then you can just say hello for testing. So you can see that nothing happens when we start, but if we move to the left, once that tile reaches to the left, it says hello. And if we keep going, more and more say hello. So instead of saying hello, let's make the X go from here to all the way over here. So this is actually pretty simple to do. All we need to do is change the tile X by 0 minus, which makes it negative, the tile amount times the tile move step, which is the negative amount of pixels per screen. So you can now see that if I move to the left, here we go, it's infinitely looping and it's seamless too because of all the parameters we set up. But if I go to the right, it doesn't loop, or if I go up, it doesn't loop, or if I go down, it doesn't loop either. So really quick, just to show what this is doing, I'm going to load this project into Turbo Warp. So in Turbo Warp, I'm going to turn up the custom stage size. As you can see now, the screen is wider. So now you can see what's going on behind the scenes. Once this tile reaches to the right, it just infinitely teleports, and usually because of the small screen size in Scratch, you can't see that looping. But with Turbo Warp, you can make the screen bigger so you can actually see the looping in the background. So now let's make sure the other sides loop as well. So now let's go ahead and do it for the other side. So duplicate this and check if 0 minus X is greater than the tile loop cap. Then for now, let's go ahead and say hello. So if we go ahead and do this and move to the right, now it says hello. So that means that this is working, so let's loop the tile. Duplicate this code and just take out the 0 minus, so that way it's just the positive. Now you can see if we've done everything correctly, when we go to the right, it also seamlessly loops, as you can see, or if we go to the left, it loops as well. So now we can go both right and left infinitely, and it will always loop correctly. If we make the camera movement faster, maybe like 25, you can see that no seams appear. It's perfectly seamless, so the system is very good. Okay, so we done the X, so now we need to calculate for the Y. So we need to go ahead and calculate the Y cap. So set the tile loop cap to the tile amount Y times the tile move step times 0.5. So now we have the new loop cap calculated, so check if the Y is greater than the tile loop cap, then we go ahead and just change tile Y by 0 minus tile amount Y times the tile move step. Make sure yours looks exactly like mine, and if I start this game, when I move down, as you can see, it's now seamless on the Y as well. So now we have infinite scrolling for right, left, and down, so let's do the up now. All we need to do is duplicate this and check if 0 minus Y is greater than tile loop cap, then change the tile Y by just that without the 0 minus. So now if we go ahead and go up, it is is also seamlessly looping. Look at this. We can go in all 4 directions, right, left, up, and down, and it seamlessly scrolls, and you can't see the seam of all the tiles looping. And this is very good. Make sure yours works just like mine. Otherwise, this whole series won't work for you. Okay, so really quick, I wanted to showcase some possible errors. That way I can help you troubleshoot if something is going wrong. So the first area that could go wrong is your sprite size. Make sure that it says 8 by 8. The next one is not setting up the variables correctly. The tile scale should be 5. That makes the tiles perfectly fit on screen. The tile sprite size should be 8. And then the tile move step is tile scale times tile sprite. Make sure you set that correctly. It can be the other way around, it doesn't matter. And then the tile mount X is this algorithm. Make sure you copy it correctly. So it's just a +1 like this, then a ceiling of, and then a 480 divided by move step like that. And same thing for the Y, just 360. Then make sure you set the tile X to the move step times 0.5 and repeat the tile X on the outside and tile Y on the inside. Another problem that could happen is if you create the clone after you change the Y by. Make sure you do it before. Lastly, another big problem that could happen to you is not setting the right variables to for the sprite only. All of the variables in this project so far besides the scroll X and Y should be for the sprite only. Thank you all so much for watching the first episode in making a 2D tile game. If you enjoyed this video and are excited for this series, and make sure you hit that like button and consider subscribing. But anyway, this has been Owen, and I am out.